Now the magic. We are going to be able to solve, not just factorise, but solve polynomial equations that have higher degree than 2. So you should already know how to use the null factor law to solve a quadratic equation. If I can factorise this quadratic, if I can write it as a product of 2 factors, then I can make each of them equal to 0 in turn and find solutions. If I have something that's higher degree than 2, I might have a cubic polynomial. I'm going to try to find a linear factor, x minus 1, x plus 1, x minus 2, x plus 2. If I can find one where if I plug in that value 1, minus 1, 2, minus 2 and get 0, I know I'm going to get no remainder. And that means I've got a factor. Well, if I've got a factor, I can do the division using long division. I can do the division, and I can write my polynomial now as a linear factor and a quadratic factor. But if I've got a quadratic factor here, I can factorise that as before. I'm going to end up with 3 terms in a row, and I just have to make each of them equal to 0 in turn, and I should end up with 3 solutions. In general, a polynomial of degree n will have n solutions. Sometimes a solution is repeated. We're going to use this as a general strategy. We're going to solve a polynomial equation, polynomial equal to 0, by factorising the polynomial and then using the null factor law. To factorise the polynomial, I'm going to use the factor theorem to try to find a value that I can substitute that gives me a remainder of 0. Once I've got one of those, I can use long division to find out the quotient. I've now reduced the degree by 1, and I just keep factorising and keep factorising. Now, why don't you have a go at this question yourself first before I do it in the next video?